Alright, so welcome back again. My name is Jesse, and in this wonderful and exciting tutorial, we're trying to do a very simple exploratory data analysis from scratch using a very nice dataset from UCI, right? So there's a particular dataset we're using, which is this particular one that we have, which is on Drug Review Dataset. So we're trying to see how to explore this particular dataset, right? So if you go to this particular website, we have some simple information. So the various things we can do with this particular stuff is that we can do classification, can do regression, can do clustering. Very interesting and very exciting. So the dataset provides patient reviews on specific drugs along with related conditions and a 10-star patient rating. So that means that there are a lot of things we can do with it. So we're trying to see how to explore this particular dataset, right? So if I go back and I check the dataset information, it's giving us the same thing that we had above, and then the intention, right? So it means that we can do sentiment analysis on this particular dataset because it's having reviews. And then if you go back again for the attribute, you can see that we have the drug name, which is categorical. We have conditions, we have review, rating, date, and useful count. So these are the stuff about it, right? So let's see how to work with this particular dataset. So I just come back here, and then we'll download our dataset. So if I go back to the data folder, click on this one, then now we can download this. So if I click on it, it's going to download it perfectly for us. Then you're going to work on it. So it's quite huge, right? I've already downloaded it. That's why you can see it from here. So let's start with it. So I'll come back to my notebook, and then let's see. So the basic tools we'll be using for this, our sample tasks that we'll be using for the EDA, we mostly be using Pandas and NumPy. Then for the data visualization, we'll be using Seaborn and Matplotlib. Then since we have review, right, and then we have some test data, we can also do some simple NLP tasks. So we can extract entities from it. We can do sentiment analysis with TextBlob. We can clean it with neat test, right? Then I think we can also do some ML stuff because based on what we had here, it can be used for classification, regression, and clustering. So that means that we can do some ML stuff with it, right? So using the review, we'll be able to predict the rating, right? Something very interesting. So let's start with this. So this is the attribute that we have. So from the drug name, we have drug name, condition, review, rating, date, and then useful count. So based on this, we can actually, before we start, we can ask some questions, some basic questions on it based on this simple information on the attribute. So since we have drug name, can find the number of, can have questions on drugs, can have questions on conditions, can have questions on review, conditions on the rating, and since there is date, we can also see the distribution or the time, right? Distribution of or the trend of all the reviews and the rating, right? Very interesting. So let's see some basic questions we can ask on this our dataset before we start. So these are some of the questions we can ask. So we can also ask, what is the most popular drug, or what is the, how many drugs do we have, which is a very interesting question. So what are the groups of drugs used, which drug has the best review, which drug has the worst review, the number of drugs per condition. So we have conditions there, right? So these are some of the questions we can ask. So we'll be going through each and every of these questions and then be trying to explore our dataset for that. So stay tuned with me. So we'll be importing our EDA packages, which is Pandas and NumPy. Then we'll also be importing our data visualization packages using Matplotlib and then Seaborn. Then for our sentiment analysis, we'll be using TextBlob, right? So these are the questions on the drug. So how many drugs do we have? That's the first question we're trying to answer before we move on to the most popular drug. So these are the questions we'll be answering. So how many drugs do we have, right? Questions on the drugs only. So what is the most popular drug? What are the groups or classification of drugs? Which drug has the best review? The number of drugs per condition? The number of patients that searched on a particular drug. So let's start with drugs. So I'll load my dataset. So it's going to be my df, right? pd.read _csv. Now passing my. So if I go back to the sidebar here, you can see that I've already extracted the dataset. So it's inside this particular folder called drugs.com, right? This particular one. If I go to this drugs.com, we have two datasets. We have the test raw.tsv and then drugs.com train _raw. So they have already divided for us, right? But let's use only the train. Then later on we'll try and see when we are working on the prediction aspect, we'll work on the train and then the test. So this is a TSV, not a CSV. So that means that you have to use a tab separator, right? Not a comma separator. So I'll just come back here, go back to my drug.com, right? So drugs.com here, / then the name was, so we are using the train, not the test, right? And it is TSV, so I'll use a separator of _ no, of backslash. So the separator is going to be /t, right? That's very simple. It's going to read it perfectly as a CSV using the tab as the separator. Very interesting. Then now we can also preview our data set. It's going to be df.head. If I preview this data set, you can see that we have these columns. We have the name, right? Drug name, the conditions, the review, which are test, the rating, the date, and the useful count. Very interesting. So I can actually check for the column consistency. So the columns will be df.columns, which is going to give us the drug name. All of them are actually okay. Now let's move on and check for missing values. So it's going to be my missing values. So df.isNull.sum. So we're going to check for the values that are missing, right? So based on this that we are seeing, we can see that the condition column, right, have 899 missing values. So the implication or the interpretation can be that this is going to be a simple narrative. A simple narrative is that either people do not want to show their condition, so most of the condition, like most of the missing values, most of the missing values are in the condition field, right? Condition column or field, right? So and then this implies, or you can just infer from this that this implies that most people don't know their condition, by name. They may know the symptoms, but they don't know the condition itself by name, right? So they can describe what they are feeling, they can describe the symptoms and the signs, which you may see, but they may not know the name of it. So don't know their condition by name, right? And then the other one is that this may be like private stuff, so privacy, right? So you understand why it's like that. So some people don't want to tell you their condition, so that is another stuff there. So these are the stuff we can imply. That is why we have a lot of aids, a lot of missing conditions. But you have the drugs, you have the review, you have the rating, but the condition column is actually having a lot of missing values. So this may be the reason. Either they don't know their condition by name, or based on privacy stuff, they don't want to tell you their condition, right? And it's very true. Most people go to buy drugs, but they don't tell you the condition. Now we are done with something simple. Now let's move on to our main task, which is going to be our questions on our drugs, right? So the questions on our drugs that we're supposed to ask were many. So I have already pasted it here so that we will be able to track what we are doing. So these are going to be these are our questions that you are going to be answering. So these are the questions on our drugs. So what is the most popular drug? So the first question is, how many drugs do we have, right? That's going to be our first question. So how many drugs do we have? So that's going to be our first question. So let's start with it. So this is going to be questions on drugs. So how many drugs do we have? So inside our database, or inside our data that we have here. So let me correct it one. Okay, so let's start. So how do we find the number of drugs within our dataset, right? So how do we find the number of drugs there? So I can just go with my df, the column name, which is drug name, right? So that's going to list all the drugs for us. Then we're going to find the unique drugs. Some of the drugs may be repeated, so we'll be using unique to find all the unique drugs. I'm going to convert it to list so that you can see it all, right? Perfect. So this is going to list all the drugs for us. So valsartan, Otoevra, all of these drugs, right? Very interesting. Now we can also count them. So to get the number of drugs that we have, so I can just go back to the same thing and then use length because it's a list. So length. Then now we can get the number of drugs. So there are about 3,436 different drugs within our dataset. Very interesting. So we are done with one of the questions. So the next question that we had is that what is the most popular drug, right? So what is the most popular drug? So that is the next question that we have. So so we'll be trying to see the drug that we have using their value count, right? So let's see how to do that. So it's going to be the same thing that we did. So it's going to be df, then my drug name. I hope you can see it very well, right? Then from here I'll just go into my value count. So we are using the value count to help us find our most popular drug. So if I go with this option, I'm going to list all of them for us. So these are the most, every drug within our dataset, and then they have the number of times they are within our dataset, right? So that's the value count. Very interesting. So we can actually get the top 20 drugs that are used within here. So in that case, it's going to be my going to be top 20 drugs, right? Oh, so these top 20 drugs are they going to be the most popular or most used, right? Most popular. I don't know whether the spelling is correct. Anyway, we take it like that, right? And I just go with dot n largest using heap behind the scene. So I just go with 20. So it's going to be the top 20 drugs there. So, and you can see from here that levonorgestrel, right? All these estrol are hormonal drugs. Same with estradiol, right? So most of the drugs that we bought are usually hormonal drugs. That is something that we can get from it, right? So I can actually plot this one out. So let's do a simple plot to make it look nicer. So I just come back here, and then I just go back to dot plot. The kind is going to be bar. Then I can just give it figure size, right? Figure, then fixed size is going to 20. The figure size is going to be 2010, right? Something very simple. And then I can also give it a title, so plot.title. Then I can just give it like top 20 most popular drugs or most commonest drugs used. These ones are based on count, right? So plot.show. It is going to give us a very nice plot. Perfect. So 20 most popular drugs based on count. So we have these drugs, right? Very interesting. So these are the most commonest drugs. So from our analysis, we can realize that the most commonest drugs here are usually drugs. These two drugs are the most commonest, and then mostly they are hormonal drugs. We can also give a simple narrative for this simple stuff. So let's give a simple narrative. This is based on domain knowledge, right? So narrative. You understand why I'm saying that later. So the narrative is that most of the commonest drugs are hormonal drugs. Right? Very interesting. That is something very nice. Now we can actually move on and then check for the least commonest drug using the same thing that we did. So in that case, it's going to be the same thing. I just copy the same thing that we did, then move it from n largest to n smallest, right? So in that case, it's going to be n smallest, right? So these are going to be the least drugs, and I'm sure it's going to be a lot, right? So this is going to give us all of these drugs. So these are the least common drugs, and even if you plot it, it's going to be a simple bar, right? So these are the least drugs there inside our database. Some of them are not even very common, like streptokinase, right, which is an anticoagulant. Like all of these drugs, they are mostly not used by people. Calcium, vitamin D, which is actually most people prefer to buy vitamins, but they prefer to take fruits. And most people will not even give a review on vitamins. Okay, so this then plot kind is equal to bar, right? It's going to give us a simple plot. All of them are going to be on the same level, right? That is something simple for that. So we have seen how to answer two questions on our data set. So how many drugs do we have, and then what is the most popular and then the least popular drug. Now let's move on to the next question on what are the groups or classification of drugs used. So I just come back here and then let's work on it. So I'm just going to come back. That's going to be our next question. So in pharmacology, we were taught that in pharmacology that all drugs, right, can be grouped. Most of the drugs can be grouped or classified based on their surfaces, right? So you can use their surfaces or their ending to group drugs, right? So that's something you should remember. So in case you want to know the particular class a drug belongs to, a particular group a drug belongs to, so something like penicillin, amoxicillin, all of these drugs belong to a particular class, right? So we were taught that in pharmacology or in med school. So let's see how to use that same idea to be able to classify and group all our drugs based on their surfaces and then their ending. So if I go back to Google and I check for this, so drugs and their right classification by endings, right? You can see that I've already searched for it. There are a lot of them. We have this one here, we have this one here, we have all of these ones here, right? All of them here. So if I go back and I check this one here, So let's click on this. Just from Quizlet, it's going to give us the drug and then the particular group they belong to based on their surfaces, based on their enders. It's taking some time for it to load. So these are all the drugs, right? So I've copied these ones. So if you see any drug with this particular ending, that means that they belong to this particular group or classification of drug. Very interesting, very nice. So this is one of them. So I've copied this one here. I'm going to copy this. I'm using these ones to help us with our classification of the drugs. Then let's check another one. So we're going to the almighty NLB from NCBI, which is a very powerful database. Right, this is a trusted source. So the other one is also trusted. So you can see from here that we have the stem or the surface and then the particular group of drug they belong to. Right, so I'll copy some of them and I'll be using them to build our stuff. So let's come back here, and then these are the ones that we have here. Right, so I've copied them, so the drug and then their surfaces. So we're trying to use that same thing to classify our drugs. So I'll load this one here. Then let's give some space and work on it. So let's start. So I'm going to create a simple function. Let's call that function as classify drug. So that's the name of the function. Then the drug is going to take the drug name, and then we are using the ending of the names, right? So the ending of the drug name, the suffixes or the suffixes we're using to help us group the drug. So it's going to be for I in my drug surface dot keys. You are looking through the keys, you are picking all these things, statins, all of these things. Then I'm going to compare it with our drug name, right? So it's going to be my drug name. So if the drug name ends with that particular key, right? So ends with I, then let's say print true, right? And let's print the drug itself. So it's going to be the drug surface. I'm going to print that particular the value, right? So something like that. So that's a simple function I've created. So let's check this simple function. So I go with classify drug, right? And I pass in, let's pass in something simple. So we pass in valsartan. So valsartan. So if I go with valsartan is inside our database. So now it is an ARB blocker. So what is an ARB blocker? If I come back here, ARB blocker is angiotensin 2 receptor blocker, right? So if I go back to this place and I check for it, cool. Let's go with Control F, Satan. And now we see we have Satan here, which is an ARB, right? Angiotensin receptor antagonist or blocker. So if I paste in this losartan here, right? If I paste in losartan or penicillin, based on inside our function, it's also going to give us something simple. So classify the drug. Now pass in this one, right? It's going to give us, it did not return anything because of the ending, so we have to make sure that the ending is correct. So true, right? Very interesting, very nice. So we're using the same simple function that I've created to group all our drugs into their respective classes. So let me modify this my function, take out the prints, and let's return some stuff. So I'll take off this print, and then we will return our drug, not the stuff. So it's going to be this option, return this, right? So something simple. So let's try it again. Classify drug, now passing the drug that we have, which was valsartan, which is an ARB. Perfect. So it's working perfectly well. So our drugs classifier is working, right? Something simple. So we're using this one to help us group our drugs. So I just come back here. Now go back to this place, to drug, the drug class, right? The class that the drug belongs to, which is going to be my df. Now passing my drug name, which in this case was capital N. Dot apply. Now passing my function, which is classify drug. It's going to take some time for it to run. Then I'm going to classify them and store it inside this particular variable called drug classes. Perfect. So if I go back here and I check it out, so let's check it out. This So if I go with my drug name and then the drug class, supposed to be this. Perfect. So see that this one was able to give us as Vasatan, but these ones were none. Some of them were none because we limited our dictionary. But if we get time, you can actually copy all of these things, make it very nice, make it very cool, then to be able to classify it 100%, like at least majority of them. Some of them it did not see, that's why it gave us as none, right? So very interesting, very nice. So we have seen how to get it. Now let's see. We have seen how to classify our drugs. So let's see the next question. So the next question is going to be, how many groups do we have? Right, groups of drugs by classes, right? By classes. So it's going to be the same thing. So df, then we have our drug class, right? From here, and I'm just going to go with my unique, then to list. Go to list, it's going to list them perfectly for us. So we see that we have ARB, angiotensin receptor blocker, we have antifungal drugs, wow, except metronidazole, we have oral hypoglycemic drugs, we have opioids, we have antibiotics, wow, we have anti-ulcer drugs, we have beta blockers, ACE inhibitors, all of these different types of drugs. And I can also come back again and check for the different groups. So this is going to be the different unique class of drugs we have, plus none. And then this is going to be the length. If I check it now, so I made a mistake here, it's going to be this, right? So we have about 23 different groups of drugs based on the simple function that you created, right? If you make the function better, we can get different groups, right? So these are the different, how many groups of drugs that we have, right? So very interesting. Now let's do some simple stuff on our drug group. So we want to see which of these drugs are the most commonest, right? Which of these group of drugs are the most commonest? So which class of drug is the most commonest, right, in our data set? So it's going to be this. We have our drug class, just as we did above. Then just go with my value count and let's check it out. So based on what we have, based on our data set, the most commonest drugs that we have, group of drugs that we have, is antifungal drugs, followed by opioid, right, which makes sense, followed by hypoglycemic and antibiotic. So we can actually plot this one out. So let's plot it. It's always nice for you to plot, to make them plot. If I go back here, then just go with dot plot. So the kind is going to be bar, right, and let's make it like this. So plot dot figure size. This figure size can be placed inside the plot, right? That plot function is still going to work. Then let's give it a simple description. So plot.title, this is going to be the distribution of let's say of drugs by class, right? So plot dot show. So we're using matplotlib to help us plot our graph as another drug. Perfect. So you can see from here that the most commonest group of drugs there are antifungal drugs. We have opioids followed by opioids, oral hypoglycemic, antibiotics, anti-anxiety drugs, right? So these are the most commonest ones, and the least commonest ones are these ones here, anticoagulants. So anticoagulants are usually not drugs that are used to stop clotting, right? Anticoagulant. So that is why it may be least used, right? But these ones, which is the antifungal drugs, which is usually skin drugs, and then we also have opioids, right? People like to take pain drugs, like painkillers, which is very common, so it makes sense. Then also hypoglycemic, which is for diabetes, and an antibiotic, so it makes sense, and an antidepressant. So these type of drugs actually make sense with our reviews, right? So a simple narrative we can give you that. So narrative is narrative 1R or double R. Okay, so the simple narrative that's like the most commonest class of drugs, or class or group of drugs used is, so we have the most commonest being, we have antifungal, which is usually antifungal drugs can be for skin, right? and you can also have like opioids, which is painkillers. So opioids and analgesic, which makes sense because most people go to the pharmacy to buy painkillers. Any small pain, they just go and buy painkillers, even if it's stomach pain. Then you also have oral hypoglycemic. These ones are for diabetes. Glycemics, right? These are, see how I spell it? Yeah. Glycemic, right? So this is for diabetes, or let's call it DM for short, diabetes mellitus. And then we also have antibiotics, which makes sense, right? Antibiotics are a lot. Okay, these are the most commonest group of drugs within our dataset. Very interesting, very nice. Now let's move on to another question you can also ask on the condition. So we have seen some simple distribution. You can also actually see the list. We already know the list which was used here, right? These are the list here. You can see it from here. Now let's move on to the next group of questions. So let's check and see whether we have finished all the questions on our drugs. So we have, what's the most popular drug? How many drugs do we have? Number of drugs per condition, number of patients that search a particular drug. So let's check for the next one, which is the conditions, right? Then you use the same conditions to help us with that. So I just come back here. So this is going to be questions on our conditions. How many conditions do we have? It's going to be my DF. It's going to be number of conditions you have. So number of conditions. So it's going to be my this, and I'll go with my conditions. I check it out. These are all the conditions that we have. I can actually go with unique, as we did above. So these are all the unique conditions that we have, which is quite a lot. Then I can count them. So these are all the different conditions that people have. So we have LVD, like left ventricular dysfunction. We have opioid dependence. Wow. Emergency contraception, migraine prevention, UTI, HIV. Wow, that's a lot. Almost every kind of disease is there. Okay. So wow, that's a lot. So let's check it out. So I'll come back here, and then we can list it out. So length, paste it here, then to list, right? So this is going to give us, wow, so we have about 885 different conditions within our data set, right? So that is going to be the simple narrative. We have 800. Oh, that's a lot. So narrative that we have 885 different conditions within our data set. So these are the different conditions that we have there. Very interesting. So we have seen one of the questions. So these are the number of conditions that we have. We can also check for the condition and then their distribution. Which of the conditions have the highest, right? So it's going to be our distribution of conditions. So distribution of conditions. So let's check the question and see whether we are on track. So the question is going to be, how many conditions do we have? We have gotten it. Which condition has the most review on drug, right? So that's what we're trying to work on. So which condition have the most review on drug? So in that case, it's going to be something like this. So my DF drug, or condition rather. So let's check it out. So now I can actually do something like this. So value count. If I go with value count, it's going to count it perfectly for us. So this is the distribution of conditions, right? Per count, right? Very interesting. So the highest there we can see is birth control. And then if you remember a previous time we were checking for the distribution of the drugs itself, the highest number of drugs there were for, what do we call it? Were for hormonal drugs, right? So birth control is also hormonal drugs, right? That explains why, right? Very interesting. So we can actually make a simple plot on that. So let's go back on this, copy this one, and get the top conditions, right? So this is going to be it's going to be distribution of conditions, right? So we're going to get the most commonest conditions within our data set, right? So the most commonest condition, value count dot n largest. Then let's go with, let's see, the 20 most commonest conditions. The 20 most commonest conditions are these ones. then I can actually plot these ones to make it look nicer. So if I come back here, plot the kind, go to bar, then as I said, I can also put the figure size here. So I can actually put figure size here. It's still going to work. Right, there's another way of doing it. These are the most commonest condition. So the most common condition is birth control. So birth control is having the highest condition there, right? Followed by depression, and then followed by pain. So we learned that opioids were also one of the most commonest group of drugs used. We also have anxiety. So it's following the same trend, but based on this condition, the number of people that have birth control conditions are so high, right? Birth control. So that is the highest, most commonest condition there. So that is going to be our narrative. So narrative. So the most commonest condition is birth control, right? So that's the most commonest condition, followed by depression, and then anxiety, and then pain. So followed by depression, and then pain and anxiety, right? So this makes sense based on the as compared to the drug distribution, right? The drug distribution. It makes sense, right? So that is simple narrative that we have written for this one. Now let's move on to some other stuff you can also do with this. We have gotten some simple questions on the condition. So we have gotten the distribution of the condition, then the most commonest condition. You can also do the least commonest condition too, which is going to be the opposite. So I can also copy this one and then do the least commonest condition based on count, right? So in that case, it's going to be n smallest. So going to give us the least commonest condition, and almost all of them are going to be 1, just as we know. So these are the least commonest condition that we had in our database. In our data set, we have hemophilia. Well, it makes sense. Ligonia, pneumonia, which comes from a condition, excessive usage or staying inside the condition. So this is going to be least commonest. So let's make it like this. So I'll copy this one here, and then this is going to be for the plot. Then before the plot, let's put it here, right? So these are the least commonest. So we have hemophilia B, Ligonia pneumonia, as I said earlier on, upper lip spasticity, right? This is supposed to be fungal infection, fungal. Decium disease, stomach cancer, right? So these are not very common disease, or these are surgical. This is genetic. Hemophilia B is mostly genetic, hereditary genetic. We also have Ligonia pneumonia, very rare because people that it only occurs mostly in their condition, right? And then we also have corneal ulcer. These are also rare. Stomach cancer, ventricular arrhythmia, very common, but I don't know why it is. Maybe because people don't see it and they die off. So that is something simple, right? You have gotten some interesting insight from our conditions and then our drugs. Let's move on to some other stuff you can also do. So there are some other things we could have done with the classification of the drugs, right? When we classify them. So let's go back and check and see whether you can do those things there. Right, so let's see, before we move on, let's combine the two. So we have done on drugs, we have done on conditions. So let's combine them. So drugs and condition. So let's come back here and ask some questions on drugs, and condition together, right? It's going to be questions on drugs and then conditions, right? Something very simple. That is a simple question. So one of the questions can ask is that how many drugs, right? How many drugs per condition, right, is being used per condition, right? Something like that. So how many drugs are being used per condition? That's a simple question we can ask on this, right? That is combining the drugs and then the condition. So in that case, it's going to be something like this. So let's come back here. You're going to be grouping them by the condition. You're going to count the drugs. So it's going to be df condition. I'll just go with df dot group by. You're grouping everything by the condition, right? I'm going to get the drug name, right? Perfect. So if I go with this option, I can just go with the size. It's going to list them perfectly for us, but this is okay, but not the best. So you can actually get the unique one, because some of them are repeated. So that user found this comment before, these are not important, so some of them are being repeated. So the best way is that we can just go with the same option and go with n unique, number of unique, right, number of unique. If I go with number of unique, it's going to list them perfectly for us, right? So these are the number of unique, right, which is better than the previous one, right? So if I come back to this place and go with n largest, or I can just leave it like that. So let's get the n largest, so 20. So you're going to find how many conditions drugs per condition, right? So that is something simple. So this one we are using the largest, top 20, right? So you're just getting the top 20. So based on this, we realize that not listed another, it makes sense because the person did not list the condition. Pain is also having a very high number of drugs. So the number of drugs that are used for treatment of pain in our dataset is very high. That's about 200. The number of drugs used for treatment of birth control is about 114. So this is going to be the number of drugs, how many drugs per condition are used. So I can actually plot this one out in a very nice format, right? So these are the number of drugs. So let's make it like this. Dot plot kind is equal to bar. You can use Seaborn to plot this one if you want, right? It's still going to work, right? Perfect, because I'm not even use any of them. So plt.title is going to be number of drugs per condition. Right, so these are number of drugs drugs per condition. plt.figure figure size 2010, right? Perfect. And then we can actually plot this one out. So POT, you can actually add the label and all of these things to it. So POT.sLabel, if in case you want to do it like that, but let's go on. It automatically generates POT.show, right? Going to give us a very nice plot. Perfect. So the number of drugs per condition. So we have these drugs. So per non-listed is high, right, which is quite huge. You can even add a grade in case you want to add a grade to it. You can also add a grade to it. So it's going to be, I don't know whether it's POT.grade also. Right, so I think it's POT.grade. Yeah, I forgot. Yeah, there's grade. Yeah, perfect. So that is in case you want to add a grade to know where it is. So it's like POT.grade, but a grade here. So this is for the number of drugs that is non-listed, and this one is for which one? Based on it, you had it for pain, right? Birth control, that is the following one, and then you also have high blood pressure and then acne. So these are the number of drugs. So they are different. There are more drugs for pain than for the rest, right? So I can actually reduce this one in case you want. So let's make it 15. 1510. Okay, right, perfect. So that is this even bigger than the previous one. Okay, anyhow, so we have gotten it. You have gotten an understanding about it. So our simple narrative is that pain, right, birth control and high blood pressure have a lot of drugs for their treatment than the rest. So I can just come back to this narrative. It's going to be so the most, so we can be like this. So pain, birth control, and then high blood pressure have the highest number of different or unique drugs for, right, they have for their condition, right? So something simple, right? That is something simple that you have done. Now let's move on to, you have combined our drug in our condition. So there are other stuff you can also do with this particular stuff, but let's move on to what I was saying earlier on about the classification of the drugs, right? So we come back again and then do some simple plot on it. Right, so let's check that one out. We'll do some two plots, then we move on. So this is going to be the on for the different conditions, right? So this is going to be just for, not for the conditions, but for the this particular plot that we did on the classes or the group of drugs, right? So I'll come back to this place, then just create some simple two plots for it. So there's that way we can do this value counting that we could have also done like this. It's going to be the distribution of drugs per drug group, right? Based on the value count, based on size or the count. So in that case, it's going to be something like this. So I can just create my df and I'll just go with dot group by. I can also use group by, and I'll pass in a particular class, which is drug class. Something very simple, right? I just go with dot size. If I go with this option, there's another way of doing it. It's going to give us all of these things, and I can actually, it's going to count the number of times this ACE inhibitor appears in our data set, right? So I can actually put this one inside a particular variable. So let's call it as my drug group, drugs group, right? So this is going to be the drug group, or let's make it drug groups, right? And then from here I can actually convert it to a data frame and then print it out. So let's convert to df. So this is going to be our first method, method 1, right? So the method 1 is that we can actually, since this is actually a series, if I check it here, if I check for the type of this drug groups, right, it's a series, Pandas series, so I can actually convert it straight to a frame, right? So that's going to be the first method. So in that case, it's going to be my drug groups dot to frame. I think it's like this, right? Perfect. So it's automatically going to convert it to a data frame for us. Very interesting. That's one way. That's the method 1. The next method is to use the other one, which is the one I prefer. So this is going to be method 2. So copy this one. So convert it to method 2. So then method 2 is I'll be using Pandas data frame, the pd.data frame to help us do that. So in that case, it's going to be like pd.data frame. It's another way. Then you're going to pass in your column name and then your count name, right? So in that case, it's going to be like this. So it's going to be our column name. So I'll pass in a dictionary. So this dictionary is going to be my drug, the class, right? Which is going to take this particular stuff here, dot index, right? Because it's a series. Then the next one is going to be my count, right? Which is going to be my drug groups dot values, right? I'll close the dictionary and I'll close it. So this is another way of doing it, right? Perfect. So this is a very nice format. So this, I can actually equate this one to my drug groups dot df, right? Something like that. There's a data frame for that, and I can actually plot it out. So let's do a simple plot and then we move on straight away. So in this case, we're using a seaborn because I've not used this. Let's use a seaborn plot to make it more nicer. So plt dot figure, to my figure size, let's use 2010 as we have been using. Then from here I'll just go with my g, right, for storing inside a variable called g, then cns, right, sns for seaborn dot bar plot. So inside my bar plot I'll pass in my y and then I'll pass in first of all my data, which is going to be my drug groups df, right? Then I need to pass in my x. So the s is going to be my, I can use the count to be my s or any of them as you wish. So let's use the drug class as going to be the x, and then for the y you use the count. So if I come back and I do it plt.show, it's going to plot it perfectly for us, giving us an error. So the name error, is that drug groups df is not defined. So it's supposed to be drug group drug. Okay, perfect. So this is a very nice plot with the different colors, right? But you can see that these things here, the names are not nice, right? So how do we fix this particular issue? So we try and see how to fix it. I'll copy the same thing that we have here, then you fix it, right? So in the future, in case you are doing a plot like that and you need to see this one very well, you can also try it on your own. So the solution is that we have to just tilt this one. So we can just go back. This is the first solution. G dot set, right, stix. So set underscore stix. So be using stix labels. No, stix label. Right. Now that's coming. stix labels. Let's see whether we have it here. Yeah, so we have stix labels. It's going to give us the label. Then I'm going to supply the label, and then I can also tilt it, right? So let's go back with this particular option. So I can just go back with my drag groups df, right? We are using the drag label, so draw class, right? That's the simplest one. And now I can actually go with, let's say, dot values to get them out. Then I can go with rotation. So the rotation is going to be used to tilt it. So based on the particular rotation that I want, in case I want it 30%, it's going to also put that 30% for us, or 45%, or 40, not percent, degree. So let's make it as 30. So let's print out again. And now it's going to be better than the previous one. Perfect. So now that has tilted it as 30 degrees, right? Very nice, which is nicer and better, right? So that is how to do a simple plot using Seaborn, right? So you're using Matplotlib, but we have been able to see how to get the distribution of the particular disease, right? We can also use Matplotlib to help us with that. So we can also use Matplotlib. So instead of using this one, we can actually use Matplotlib to help us with that. Or instead of going with this, the one we did above, so if we go in with this option here, right? We can just go with plt.stix, then set the rotation. So like it's going to be plt.stix. Now set the rotation as rotation, say 30. We're going to do the same thing above, right? So this is another simple way of doing it. Perfect. So this is how to do a simple plot, and that's giving us a very nice plot with their names there, right? Very interesting, very nice, very cool. So we have seen how to do some interesting stuff about the drugs, about the conditions. Now let's move on to the next step on the rating and then the review, right? So that is going to be the next questions we'll be trying to answer. So I'll just come back to where we were. So the next questions we'll be answering are going to be questions on our ratings and then our review. So these are the questions we'll be trying to ask, right? Questions on the rating, distribution of rating. You can also get on the average rating per count, right? Something very interesting. So work on the rating, then move on to the review. So let's work on the rating first. So these are the review. That is what we'll be doing next. But let's work, because the review has some tests. We'll be going with the rating, the numbers first, then move on to the rating, right? The rating first, then the review. So these are the questions we're trying to answer. Now let's check it out. So PDF rating. So these are all the rating, they are all numerical values. So in case I want to get the distribution of the rating, how is it? How do we do that? So we can actually group them. So it's going to be the distribution of rating. Rating, right, per size. So in that case, it's going to be like this. So my df, I can actually group them and then use the size to help us with that. So df.group by the column, which is rating column, or the rating field, dot size. So this is going to give us some interesting plot. So the number of poor rating is this, the number of 10 rating is this, right? So that is something simple. So I can actually plot this one out, do a simple plot. So let's check it out. You can actually even do a pie chart, but let's go straight away with this. So plot, this is simple, right? So that is a simple plot. So this is how it is, right? So the number of people that had 1 point give 1 rating is this, and the number of people that give 100 or 10 rating of 10 is this particular stuff. That is something simple that we can do. Right, so that is one of the ways. The second way we can also do is that we can actually use histogram. This is normal bar plots, but in case we want to use histogram, so this is going to be the same thing we did, but this one we're using histogram, right? So in that case, instead of using group by, we can just take the entire stuff that we have, go back with rating, right? And I'll just go straight away with this option of the hist, right? So there's a normal pandas function that's going to plot it up perfectly for us. So plot.show, then above it, let's give a title, let's give it a figure size. So the figure size, right? And then I can just go straight away with a title. So plot.title, and let's copy and paste this one there to save us time. In case you have any question or contribution, you can just put it in the comment section below, and then please don't forget to subscribe. So now I can actually put it out. So we're going to be using histogram, right? Very interesting. So this is how the distribution is. So based on our distribution, majority of the people give 10, right? Rated within 10 and 10, between this 7.5, right? Let's say 7 to 10, right? And then very few people give medium rating, and then majority of the people that found it bad give a poor rating. So that is a simple narrative you can give. So the simple narrative that most people rated at the extremes. Right, so you can see that either the person is going to rate as 1, right? 1 or 2, or none of these ones. These are very less. Or the person is going to start rating from average, that is like from 7, 8, 9, 10, right? So that is why most people rated as the extremes, right? That is a simple narrative you can get from this count, right? This simple plot. Now let's check for the next question, which is the average rating. It's going to be our average rating, right? So the average rating is going to be something like this. So I can call it as AVG rating. I'm using a simple condition to help us with that. So df, I'm going to pass in my rating, right? I'm going to pass in my rating. Then when I pass in my rating, I'm going to use a simple condition to help us with that. So this is the average rating of drugs, right? So this dot group by grouping by the drug name, right? Then I can go with the mean. Dot mean. Hopefully it doesn't fail. So key arrow, there's a key arrow somewhere. So df, so it's supposed to be this option. Df, right here. This option is better. Perfect, that's worked. So now I can just go back with this AVG rating. If I check it out now, you can see that based on the drugs, right? So these are all the different drugs, and then the average rating for that particular group of drug, right? For that particular drug. So I can also do the same thing and get them as a plot. So let's do the same thing for the top drugs. So it's going to be the average rating for the, let's not make it for the top, but for all the drugs, right? So I can just come back to the same thing. .hist, you can use the histogram to help us with that. Then I can just do the same thing that we did above. So I'll copy this histogram plot that we had, the same thing here. So let's copy this, then we just modify it to save time. So I take off this, right? And then I'll just change the direction by average rating for drugs, right? It's going to be the average rating for each and every of the drugs. So something simple, right, to save us time. Oh, you see we are taking a lot of time because we are doing everything one after the other. I spelled it wrong. Let's make it again. So based on this simple stuff that you have done, we can see that the average rating, right, we just did an average. Most people don't rate low, but most of the rating, as we did earlier on, is between the point of from 5, mostly from 5, 6 to 10, right, based on for each and every of the drugs, right. So something very simple and exciting. So we have seen how to answer 2 questions on the rating. Now let's see the other ones. Perfect. So now let's see some other stuff you can also do. So we have worked on the average rating. We can also do the average rating of, this is for individual drugs, right? These are for individual drugs, right? But in case I want to get it for the group of drugs or the class of drugs, so let's copy this one and add it to, copy this, and then we try and use it for which group of drugs have the best rating, or right. So in that case, it's going to be average rating of drugs by class, right? In that case, it's going to be not the drug name itself, but the particular category of drugs or drugs that have. So average rating per drug class, right? Man, this is too long. Perfect. So this is a long variable name, so I'll just copy this one, and just as we did above, you can actually check it out. So based on this, you can see that ACE inhibitors have, although when you combine all the ratings for ACE inhibitors, the group of drugs that are ACE inhibitors is 5. If you combine the same thing for alpha blocker, it is 6, anxiety is 8, antibiotics we have 6, 6, 7. The highest there is 9, and I'm sure because anticoagulants are very few, and then the rest, right? So you can actually plot this one too, as we did above. So I can just come back to the same place that we did and use it to plot it out. So I'll come back here, and then let's use the name that we use for this one. So you can see that from a simple data set, we have been able to explore different things, right? We've been able to explore different things. So I can just copy this one here, description of every drug for drug class, right? So these are the different drug classes. Perfect. So you can see from here that some of them were not properly done, but at least we get it, right? You get the point. So that's something very simple that I have done. Now let's move on to the next stuff, on questions on the review. So I was thinking, is it possible for us to find the drug with the most review, right? We have gotten the drugs with the highest group of reviews, right? You have gotten these ones. From these ones, you can know which group of drugs have the highest review. So let's try that one. Hopefully it's able to work. So I'll copy this, and then let's check it out. Let's take off this plot. This is something I'm not trying, so dot n largest, let's go with 10, right? Wow, it worked. So these are the drugs that have the highest reviews. So which group of drugs have the highest mean or average rating, right? So these are the drugs that have the highest mean or rating. So we can see that anticoagulants have, right? And I'm sure because they are small, barbiturates, which like diazepam, neuromuscular blocking agents, anti-anxiety drugs, pituitary hormone beta blockers. So these are the 10. So we can make it 20, like we have been doing, right? It's still going to work. So that is the group of drugs that have the highest mean or average rating, right? You can also try it on, you can actually plot this one out in case you want to do that. You can also try it on something else. So this was for the highest mean. You can also do the same thing for the drug itself, per drug, right? Not for the group of drug, but for the per drug. So which drug has have the highest rating, right? So these are the drugs that have the highest rating. and then most of them are going to be 10, so we have to filter them out. That's why we worked with the group of drag, right? So all of these drags, very cool. Now let's move on to the next question on the reviews, right? So these are going to be the questions on the reviews. Then we move on to do some other stuff. But before we move on to the reviews, there was also something they call the useful count, right? So there was, if I go back and I check the columns here, there was also the useful count, right? So this useful count. So later we'll be trying to see the useful count later on and see whether I'll be able to work on it. So that's going to be something else. So let me give some space so that we don't forget. So this is going to be for questions on useful count. So the useful count is trying to tell us that based on the reviews, right, how many people benefited from the reviews, right? That is the basic understanding behind it. If I go back and I check it here, from here, let's check our documentation. It gave us some simple description here, right? So useful count is the number of users who found a review useful, right? So these are the number of people that found a particular review useful. So I'll copy this one to help us know what the useful count is, right? So that is the basic understanding behind it. So we can know the number of users who found a review useful for a particular drug. So based on, you can just do the same thing that we did for each and every of the drug and then use it for that. So based on, you're comparing the useful count and then the particular drug, right? You can also do something like that. So let's work on the review, then later we'll come back to the next one. I'll just come back to this. So this is going to be for our review. So how the first thing we're doing on the review is going to be mostly sentiment analysis stuff, and then later we'll try and see whether we can be able to do some correlation stuff, right? But for the prediction, we will leave it another time. So how genuine is the review? That is the question, right? So how genuine is the review? So to be able to get how genuine a review is, we're trying to use sentiment analysis to be able to know whether the review is a positive sentiment or a negative sentiment, right? Then you're going to compare it with our rating, right? So that if the review is, the rating of the review maybe is 10, and then the sentiment is positive, that means that the review is genuine, right? If there is a discrepancy between the review being positive sentiment and then the rating being maybe negative, that means that there's something wrong here, right? That is the idea behind it. So let's check it out. So how genuine is our stuff? So between TextBlob, so we have, it's going to be from TextBlob import TextBlob, right? Perfect. So that's what we're trying to use to help us with that. So we'll be creating a simple function. So let's check our review first. So as we learned earlier on, the reviews are test, right? So these are all test data, right? It has no side effect, all of these things. So either there are two things we can, since it's a sentiment analysis, we don't need to even clean it. You can just work straight away. But in case you want to clean it, you can also clean it, right? It's still going to work anyway. So I can just come back to the same thing that we did, and we'll create a function to, a simple function to help us get our sentiment. So it's going to be def get sentiment. I'm going to be creating two functions. So this is going to take our test, right? And then I'm going to just create a simple blob. It's going to be my test blob. Now passing my test, right? Then this is going to return my sentiment dot polarity. Right? That is something simple, right? So I'm using this simple function to help us with that. That's going to be our first function. Then we're also going to create another function. So def dot get sentiment label, right? So this is going to take the test, then going to do the same thing, blob, and then the test blob, create a blob object of the test. Then from here we're going to check if our sentiment dot polarity is greater than or equal to, if it's greater than 0, right? So 0 is neutral, and then greater than 0 is positive, and then negative is negative, right? So polarity, if sentiment dot polarity is greater than, right? So see what I'm doing, it's not supposed to be here, right? If it is, so I made a mistake here, let's correct it. We are storing inside a variable called blob, so it's going to be blob dot polarity, right? Then the same thing here, it's going to be blob. Perfect. So if it is greater than 0, right, that means that it is positive. So going to return. So let's call that our result. Going to be positive, right? Positive, right? Else if our blob dot polarity is less than 0, right, that means that it's negative. That's going to be our result. It's going to be negative. See how I spelled negative, right? That is all. Then the third one is going to be else. That is if it's 0. So else result is neutral. Any other thing, neutral, right? That is something simple that you have done. So I've created a simple function. Then I'm going to return result. Created 2 functions to help us with that. So let's test our function. So it's going to be our test function. So let's get the sentiment for something simple, something that everybody knows that is a positive sentiment. So sentiment going to be I love apples, right? Everybody love apples. So 0.5, that means that it's positive, right? So it's a good sentiment. If I go back again and I use the label on it, give us an error because we call it label. This is positive, right? So our functions are working. So we'll be using the same function to help us group or check for the sentiments of each and every of our reviews. So it's going to be df sentiment, right? And then this is going to go with my df review dot apply. Now passing my function get sentiment, right? That's going to be the first function. Now we'll do the same thing for the next one. So this is going to be sentiment score for reviews, right? And the next one is going to be sentiment labels, right? Sentiment label for reviews. So this will be for the sentiment label, right? And I'll pass in get sentiment label. So let's run our first function. It's going to take some time because it's a lot. Then later we'll run the next function. Perfect. So it has finished. So we have created two variables, right? 2 different fields, one for the sentiment score and one for the sentiment by label. So let's check it out. So I'm just going to come back here. It's going to be this my df. Now you can also check for the review. Be my review, right? Then the next one is going to be the sentiment. Then the next one is going to be the sentiment label. So let's check it out. Perfect. So you see that these are the sentiments, right? So this is a review, this is the sentiment which is neutral, and then the sentiment label. Very interesting, very nice. So we can use this one to help us to find the number of positive reviews and a number of negative reviews, right, based on the sentiment. So let's check it out. So that's going to be the next question. So how many positive reviews, how many negative reviews, right? So how many positive and then negative, I spelled the negative, and neutral reviews. I spelled the positive wrong. So that's the next question you're trying to answer. So it's very simple. We can just take that particular column, which is going to be my df.sentiment label, right? And I'll just go with .value count. Hopefully it's able to work. Put the value counts, right? Right. So this is based on our data set. This is the number of positive reviews. This is the number of negative reviews, and this is the number of neutral reviews. So I can plot this one out with .plot. So the kind to be bar, right? So you can use that one to generate a simple plot for us. Very interesting. So that means that there are more positive reviews than negative reviews, which makes sense because it's always good that people give positive reviews for your product, but it's almost like half of it, right? Almost like half. So the best option is that we're going to add the neutral to the positive so that it becomes better, right? Very nice. So we have seen how to get the sentiment on our reviews. So let's do a simple correlation analysis of the sentiment and then the rating, right? Then later on you see how many of the reviews are genuine reviews. So in that case, it's going to be our correlation between our sentiment and then the rating, right? Let's see whether I can learn something from that. So in that case, it's going to be let's use Seaborn. So sns.line plot. You're using a line plot. Now pass in my data. So data is going to be my df. Then from here, I'm going to give my x, which is going to be my rating, and then the y is going to be the sentiment, right? So in this case, you're using the sentiment score, right? So if I run it like this, let's go with plot.show. It's still going to work without the plot.show. It's going to run it and give us a very nice plot, right? So now we are comparing the rating and then the sentiment. So be able to learn something from this particular plot. Perfect. So it has finished, right? So based on this plot that we had, you can see that these are rating and these are sentiment. So as the rating goes up, the sentiment becomes more positive, right? That is the basic understanding behind it. So that means that there's a simple relation between our sentiment and a rating. So that means that if the sentiment is good, it's positive, the rating is definitely going to be high, right? That is a basic narrative. So let's write a simple narrative. So the narrative you're writing is that so as the rating goes, or as the rating increases, or the rating increases with increase in sentiment, right? That's the big understanding. So like there's a direct correlation between that. So if the person is giving a positive sentiment, positive review, that means that the rating is also going to be good. So it's going to be like this. That is something simple, but we can also do another simple plot for this using separating them, right? Separating both the positive and the negative. But this one is just giving to us as both, so we can actually do it in this way. So let me take off this and let's put another plot here. So this is going to be another plot. So in that case, it's going to be like this. So let me copy this one and paste it here, right? So we had this like this. So I can actually use a line plot to help us with that. So let's use this is going to be another correlation. This is going to be a correlation between rating and then sentiment, right? In this case, we are trying to separate them from negative, positive, and then neutral. So sns.line plot, then the data is going to be my df, my s is going to be my rating, my y is going to be my sentiment, and then we'll be using the hue, the color, which is going to be my sentiment label. So that's going to tell us how it is, right? How they are related to the rating. Taking some time for it to run. So it's going to generate one plot with 3 different lines. One for the positive, one for the neutral, one for the negative. Perfect. So you can see from here, from this simple plot, that this is how it is, right? A very simple plot. So the orange line is a positive, and then the green line is a negative, and this is a neutral. So you can see that if you even when you're considering the negative, right, the ratings are also in this particular format, and then the positive also going the same way. Still the same approach, right? Very interesting and very nice. So let's move on to how to find the genuine reviews. Which of the reviews are actually genuine, right? So this is simple feature engineering. Is how many of the reviews are genuine, right? How many of the reviews are genuine as compared to the rating, right? So we have already used sentiment analysis to help us to know if the person is giving a review, if it is positive or negative. You can also use that same thing to help us to know which of the reviews that the person is giving, even though the sentiment analysis is positive, comparing to the rating, is it a genuine review, right? So what we're doing is that we're going to write a simple function. So it's going to be something, not a simple function, but a simple condition. So for a genuine, let's make it like this. So for a genuine rating, right? This is going to be a genuine positive rating. So let's call it a genuine positive rating. Genuine positive rating, right? Right, that is positive. So the condition that if it is giving us a positive sentiment, right, positive sentiment plus the rating is more than, let's say, from 10 to 6, right, that means that it is a genuine positive rating. Then this one is subjective. Then this is going to be the opposite if it is from 4 to, so if it is from 4 to 1, right, that means that it's a genuine negative rating. Or we can even make it like genuine good rating rather, right? And this is going to be bad because positive and negative are relative. So a genuine good rating is any rating that is positive, right? The sentiment is positive, and then the rating is from 10 to 6. And the same way for the genuine bad rating is that the sentiment is negative, right? Meaning the person is actually hurt. The drug did not work. And then the rating is low, right? And then the neutral is going to be the other one, and it's 5. So let's check it out. So we can just write a simple condition to help us with that. So this is going to be our good, or you can call it genuine good rating or true. So genuine good rating. So we can just go to my df. I'm going to write a simple condition to help us with that. Go to my df, now pass in my rating, right? As I said, we are comparing the rating. So if the rating is more than 6 or equal to 10, right? 6 from 6 upwards, so it's going to be this option. 6 and upwards, that is going to be the rating, right? So let's put that condition here. I don't know whether you've seen my screen. Hope everybody's seeing it, right? And then the next one is going to be this particular option of df, which we are using. This one we are not using the rating, we are rather using the sentiment is equal to positive, right? So if the sentiment is positive, right? So that is something simple. So let's try and see whether this is going to work. I'm making a mistake somewhere, so let's correct it out. See what I did. It's supposed to be this, right? So these are all giving us an error. Sentiment label. We are comparing the label. So perfect. So these are all the genuine good ratings, right? Because the rating is high, the review is also good, and then the sentiment is a positive sentiment, right? So that is how to do it. You can also try the same thing for negative ones, for bad rating, for genuine bad rating. So in that case, it's going to be less than 4, right? Then the sentiment is going to be negative. In that case, it's a bad rating. So this one we can use it in case you are doing your machine learning aspect, but you can leave it, go without it. So these are actually bad rating. You can actually try, let's store inside the variable. So let's call this bad rating. Right, you can call it bad rating. It's going to be, or you can call it bad review rather. Right, that makes sense. It's also going to be a good review. So we can call it genuine good rating per review, right? So it is going to be good review. Same thing. Per review. So I'll save this one here. save this one here, and now we can actually check and see. So it's giving us an error. It's supposed to be this option. Yeah, we can actually pick one of them and see whether it's going to be so good review dot head, right? So there's it. So I can actually pick a review and read it and see whether it's going to give us something. So let's pick it out and check. We will read it by ourselves and see whether it's good. Which is going to be this option of my good review dot ilog. Let's pick the first one, right? And then let's go with the particular stuff. It's going to be review, right? So this is a review. Wow. My son, this is a good review, right? Good positive review. So my son is halfway through his 4th week of intuitive. I don't know. Intuitive. We became concerned when he began this last week, when he started taking the highest dose he will be on. For 2 days, he couldn't hardly get out of bed. Wow. So this person is actually expressing his heart. Was very cranky and slept for nearly 8 hours on the drive home from school vacation. Very unusual for him. I called his doctor on Monday morning, and she said to stick it out a few days. What English is this? See how he did at school. He was getting up in the morning. The last 2 days have been problem free. That means that the drug is working, right? Because the last 2 days have been problem free. He's much more agreeable than ever. That means the drug is working. He's less emotional, a good thing, less cranky. He's remembering all the things he should. Overall, his behavior is better. We have tried many different medications. So far, this is the most effective, right? So this is actually a good review that if the person reads it, the person will be able to give it a good rating, and the person will be able to buy the drug, right? So that is something very nice. So we have seen how to find the sentiment for each and every of the review, as well as to find which of them are good reviews and which of them are bad reviews, right? Using the sentiment. Very interesting and very nice. And then the rating. So the next thing we can do is that we can actually build a program, right, using machine learning. This is where the machine learning aspect comes, in which you will be able to try and build a program to predict the rating given the review, right? That is something we can also do. So let's move on to the useful count, then we move on to the next. So let's check and see whether we have been able to answer some of the questions before we move on. So this was correlation between rating and review, and then users who found the review useful. We can also actually do another correlation between them, right? So let's check that one out, which is correlation between users who found the review useful. And then you can also do distribution of the rating, which you have done already. So let's work on the useful review, right? So that's what we're doing. So number of users who found review useful. Another question we can ask is the top useful count, right? By drugs, right? So it can be by drugs and then the drug class. So that's another question as we have. So we can just check for which of the drugs are the best, right? Based on the best drugs based on useful count, which is almost the same thing as above, right? So in that case, it's going to be like this. We have our DF, our useful count, which is this particular value, right? So in case I want to find based on the value count, based on the drugs, we can actually group all the drugs by that option. So it's going to be this dot group by, then you're grouping the drug name, the drug name. I don't know why I can't spell it well. Let me change the theme for now, right? so that at least I've been taking time, so in case somebody left and came, you see that the tutorial is different. Isn't a lighting for now. Okay, wow, this was clear. Apologies. Okay, so let's go back and do some simple stuff. So it's going to be like this, right? So this is going to be the drug name, useful count. You are grouping by the drug. We're going to find the value count for the stuff. So you can use the mean right? So you can find the mean useful count for a particular drug. You can find the value count for all of them. So it's going to be value count. They're grouping them, then they're finding the value count. Perfect. So this is something simple, right? So this is okay, but you can also actually use the unique option to help us with that, as we did above. So let's use the unique to find the top drugs by useful count, right? So that is top drugs per useful count. So in that case, we are not using the value count, but we will be using the n unique, right? I spelled unique wrong. Unique, right? Perfect. So these are the unique ones. You can find the n largest. So dot n largest. So let's get the top 20. So these are the most useful. So these are the most useful. These are the drugs, right? The most used drugs, the 20 most used drugs per useful count, right? So I can actually plot this one out. So let's copy this one and then let's plot it. It's going to be dot plot. As you have been doing, using the bar to save time. Okay, so these are the most useful drugs there, right? Very interesting. Now we can also do the same thing for the group of drugs. So top drugs per useful count. So we are using the group of drugs, top drug class per useful count. So in that case, we'll be changing this one from drug name to drug class. You can also do the same thing for the negative, right? So the most important drugs, the group of drugs that are useful, that are mostly used based on useful count, is opioid, as we still the same thing, anti-anxiety, or hypoglycemic for diabetes, almost the same thing, right? So that means that there is a correlation between the useful count and then the rating, right? So you can actually do a plot for that. So dot plot kind bar plt.title is going to be the top drugs class per useful count. The naming is not correct, but let's move on like that because we are taking a lot of time. Perfect. And then now you move on to do the correlation. You can do a simple correlation. So this is drugs per useful count, right? Top drugs per useful count. You can do the list drugs too, which is going to be the same thing. So I can also copy this one for the individual drugs, and then for the, so I can also come back here, change this one to the list, right? List drug class per useful count. Now I change this one from largest to small list. So this is it. So wow. So the least drug there is anticoagulant, which makes sense. Then barbiturate for antipsychosis, pituitary hormone, just like the previous one we did, right? So that means that there's a correlation between the rating and the useful count, because almost the plots are the same, right? Almost all the plots are the same. If I do the plot for the rating, it's almost the same thing as this. So we can actually do a line plot comparing the rating and then the useful count, right? So let's try that one out. It's going to be correlation. See, my mind spelled it well, but my hand spelled it wrong. Correlation between the rating and then the useful count. You can use heat map to help you with that. Useful count, right? So in that case, it's going to be like this. My SNS dot line plot, as we did df, then we just do the data into df, then my s is going to be my rating, and then my y is going to be my useful count. So this thing I are doing, hopefully it doesn't give us an error. Doesn't become a very weird plot. So I think the best one is to find the average rating and average useful count and then compare them. otherwise it's going to take some time, right? But it worked, right? So based on this, so you can see that there's a very interesting correlation between the useful count and then the rating, right? Very interesting. So like as the rating goes up, the useful count also goes up, right? Which makes sense because the more people rate something, right, the more people use it, right? So that is a simple narrative we have. So there's a very simple correlation. So narrative, like as the rating goes up, the useful count also goes up, right? So that's something simple, right? There's a better way of writing this, but let's make it simple for everybody. Okay, so that is something about the useful count. We can also move on to do some many other stuff, but let's move on to the other stuff, the questions on the date, right? So it's going to be questions on date. Remember that if I go back and I check my columns, we had a date column, right? This is wrong. We had a date column, right? So we can actually, since we had a date column here, we can be able to check for the rating per a year, or the number of reviews per year, or the number of useful count per year, right? In that particular format. So we have seen how to work on the drug name. We have answered some questions on it. We have seen how to work on the conditions. We have answered some questions on it. So let's recap what we have done so far before we move on. So these are the questions we have answered so far, which is quite a lot. We have, with this simple data set, we have answered questions on the drugs. We have answered questions on the conditions. We have answered questions on the reviews, on the rating, and then on the useful count. So let's ask some questions on the date, right? It's going to be questions on date, right? You're trying to see whether we can be able to get some insight from the date, like a time series. So the question we can ask is going to be the distribution of rating, right, per date and then per year, right? The same thing, we can also do the same thing for distribution of reviews, right? How many reviews per day? No, per, let's make it like per year, right? Like that, something simple. These are something simple. These are simple questions we can answer. So let's work on it. Right, so that is some questions we can answer. So let's see the questions. I think we can add this question to it. The amount of review per year, right, which is the same as the distribution. You can also do something about the useful count and the rest. So let's come back here. Let's do the simplest plot, right? It's going to be the rating per year, right? Simple one, grouping them by year. So it's going to be my df dot group by grouping by the date before you convert to date time, right? That is the simplest stuff. Then from here, I'm just going to go with the rating, right? Then I can just go with the particular stuff. So let's say size, go to group by date. So based on the date, so on April 1st, these were the number of ratings, like the sum total of the ratings, right? Like that. So you can actually do this particular plot. You can also see whether you can also do mean for this, which I think that would be the best option, right? At least finding the mean of it will be better than the size or the value count. So mean. Yeah, so this is the best one, right? So this is the rating per year. So for this particular date, now collecting all the rating, this is the average rating for that particular date, right? Which is quite cool and very nice. You can actually plot this one out in case you want to do that. So rating per year, average, this is going to be average rating per day. This is not even per year, this is per day of a year, right? Of every year. Every year there is a particular rating for that particular day. So dot plot. Let's see whether it's going to give us some nice plot. Hope it doesn't get choked up. Right, so this is some interesting plots. So let me make it bigger. Let's go with the fixed size 2010. It's like a time series plot, right? can see how it works over time, right? So we can see that in April till September 29, then it goes like this, right? So like it's like a stationary graph, right? Within a particular range from, let's say, around this 8.5 and then 5.5. But some of them, during some of the years, it went down, right? That is something simple that we have done, right? Very cool. So we have seen how to answer one of the questions. That is the average rating per year, right? This is going to be the average rating per day of a year, of every year, right? So I can actually take this one, give it a description so that somebody can use it in the future. plt.title. So plt.show, right? Something simple like that. So that is one question. Now let's move on to the next question. So the next question is, we can also do the same thing just as we did for the rating. We can also do it for the particular useful count, right? So average useful count per day. So you can see that there are a lot of questions that keep on coming. It's going to be the average useful count. So it's going to be the average useful count per day. You can even do the same thing for the sentiment. So average useful count. And you can see that it's a very interesting plot, right? So these are the average useful count per day. We can also try it for the sentiment for each and every day, which is the sentiment. So this is one of the ways of doing it, right? Using group by, but you can also convert it to daytime and then pick a particular year, right? A particular day to be more precise. So it's going to be useful average sentiment. So this is going to be our sentiment score. So I'll just change it from here, this option. Sentiment. It's going to be very low, right? So this is how it is, right, for each and every year. So that means that it's just like a stationary stuff and it's moving on more like that. So this is something basic that we have done. We can actually be specific and pick it according to a year, according to a particular point, using the daytime option. So let's try that one out, right? So but before we move on, there is something simple we can do here. So let's check that one out, which is going to be the average. As our question went, the question was amount of review per year, right? So we can actually do that one a simple way. So this is going to be like this, the same thing by changing this one to review. We are using size, right, rather than me, right? So it's going to be the average, not the average, right, but rather we are using the, it's going to be amount of review. So amount of review per day, right, which is okay, but this plot is okay, but it's going to be smaller. So we can actually use a daytime to help us with that. So let's plot a simple plot. Let's plot this simple plot. Take some time. Voila. So this is the amount of review per day, right? So this is how it is, right, within the range, and it goes like that. You can actually do if we do a bar chart, right, it's going to be some way. The line is okay, but the bar charts, it will look some way. So let's try it out. So the kind, go to bar, hope it doesn't look some weird plot. It's going to take some time. Yes, I'm sure it's going to take some time. So whilst he's doing that, let's work on the time series on, right? So the time series, when we try to convert the entire stuff into a time series, this is using not to date time, is using date time index, right? So this is going to help us to be more specific, right? So I can just go back to the same thing that we have been doing so far. Let's go to date right? The date that you have grouped, or group date. We are grouping everything according to date. Then I just go with my df.group by. I'm grouping everything by date. I'm grouping everything by date, right? Then when you group by date, you're using the aggregate function. Then we use the aggregate to find the aggregate text dictionary. So we are going to find the mean for the useful count and the rating. Then we're going to plot them out, right? Because these are the two main stuff we want to do. So it's going to be my rating. The rating is going to be using numpy.me because we want to be fast, right? And then do the same thing for the next one, which is going to be useful count. You can also do the same thing for the size, anyhow you want it to be. For the review, right? Which in this case is going to be numpy.sum. We are adding them. Then let's try and see whether we can work on the reviews. Which in this case we'll be using, let's use count size, right? I don't know whether it will work, but let's hope it works. So it's taking some time for this one to do. So after that, we will convert these ones to convert the date into datetime option. So in that case, I'm going to have to just group the date, right? Now create a date column. Now set the index because this is going to create a group by. So group by usually have index. So in that case, it's going to be my group data or date rather dot index. Right, that's the first one. Then after that, I'm just convert that index into date time object, right? So date time, so pd dot date time capital index. I pass in the particular column, which is the date column. Then I can actually set it out, right? So it's going to be my group date. It's going to be my group date dot set index to the date column. Then I can do the plot, right? So we're still taking some time. So this is what we're doing. So we're going to equate it to the index. You're going to convert the date to datetime index or datetime object. Then you're going to set that particular column to our index, right? Then we can even drop it if you want. Then we can actually plot it, right? Right, that's finished, right? And I'm sure that, wow, it's a very ugly plot because of this option, right? So this is how it is, but we can make it better by using the datetime option that we are trying to talk about. So let's run it and see. I'm going to group it. I don't know whether the size will work. Yeah, the size doesn't work because name error. Name size is not defined, right? So this can be count. Yeah. Let's check it out. Right, so we use size. Size works better, right? So the same thing, but if you're using numpy.size. So let's check what you have done so far. So I'll come back to the group dates. This one. Paste it here. Let's check what you have. So we have it in a very nice format. So this is going to be better than what you have been doing, but it's going to give us the same result, right? Perfect. So you have grouped them. So per the average rating, per the useful count, per the review, right? The count, the size of the review for that particular day. Very nice. So this is a very nice plot. Now you have to convert this one into a very nice data frame that we can actually use. So I'm going to be setting the index. So let's check it out. In case I want to get all the dates, I'll just come back here and do the same thing. This option dot index. Right, if I go with it's going to give us all of them, right? So we need to get that particular date in the right format and convert it to datetime object. So that's why you're using this option, right? The first one. Then after that, you're going to do it in a better format. You're going to run it, giving us an error, type error. So let's check it back again. Everything is working as expected. Nothing was changed. Now let's do it one after the other. Right, so I'll set it to that. Perfect, it worked. Now I have to change the datetime object. So that's what the error was, right? So we have to correct the error. So datetime must be called the collection of some kind. Date was passed, right? So let's check it out. Oh, you see what you made? You made a mistake. It's supposed to be my group. You're just passing the date without passing the data. It belongs to a particular data frame. Right. You see the mistake you made. Right, now it's going to work. Perfect. Right, so it's going to convert everything to date time object. Then now we can be able to, if I check it back, if I check the data types for this, dot d types, now it's in a better format, right? So that we have our date time object, right? Perfect, everything is working as expected. So now we can actually plot them. So we can set them in this particular option so that we can actually select them. So this is setting the date, the index to that particular option, so that we can do something like this. So when we select a particular date, a particular day, right? Or date range. So if I go back and I go with my grouped date, right, I can actually do something like this. So in case I would only want 2008, I'm going to only pick 2008 for us, right? Very interesting. And I can also do a plot for that. So I can just go with plot kind. Let's go with a simple plot like this. And I'm going to plot it with that line, right? Which is quite nice. Very interesting. So this is something very cool. So this is how it goes up. So you can see that the useful count is going up, and then some of them are so small. So either we can scale the useful count, or we can only limit it to a particular one. So I can just go back again, and then let's pick only the rating and then the review, right? So I can only pick the review for February. No, I said for February, for 2008. So this is going to be select is for 2008, right? So the size of review. So in that case, if I go with this option, perfect. So this is how it works, right? So this is how 2008 went. So I can also be specific and move to, let's say, January, right? From January to February, or for a longer period of years. This is for the reviews only. So I can come back here. I prefer we put a title to it. Plot of title. For 2008, right? So this is for 2000. You can also do the same thing. So with this option, I can actually put it like this. I want 2008 to 2000 and then 9, right? You can also do the same thing. So I have to change this one from 2008 to 2009, right? So something like this, it's very good and very useful. This is a simple way and a better way, right? So you can be specific. So it's see that from the beginning of the month, this was the reviews. Then over the years, the reviews started going up, right? Very nice. Very cool. We can also do it for the entire stuff, not just for the review, but for the entire stuff. See the spelling I'll be making. Over time, right? Something like that. So you can do it for the entire stuff, not just for the review. You can also do it for the rating or the useful counts, right? Rating. So this is going to be the amount of rating, or this is distribution of rating over time, right? So let's copy this one, and then we are done. So copy this one. So thank you for watching this long tutorial. It has been quite a long tutorial. So this one I'm just using for 2008 to 2009, right? Wow. So that means that on the average, right, at the beginning of the year in 2008, the ratings were high, then it started dropping. That is quite interesting. So you can do the same thing for the entire staff, not just for the 2 years, but for the entire staff and then for only a particular set of months. So I can just do this one, take off this. Or let's make it the entire staff ends at 2012, right? I want to do it for the entire stretch. Wow, right, very cool and very nice. You can even make the plot bigger in case you want, using the figure size 2010, right? So at least it becomes bigger. Very interesting. So that is something cool. So let's do it for a specific month. This is going to be for overtime. This is for overtime, and this is for overtime. Let's use it as, let's say, day, right? Very limited amount of time. So in that case, to check for the date, because this is already daytime object, I can also do the same thing as we did. So group date, right? Then I can, if I go with this option, so we have date, right? So I can also specify the particular month. So I can make it like this. So it's going to be my 2008, right? Just as we have above. 2008 can go with 04, right? For the whole month. This is going to be for the whole month, right? And I can actually do the same plot as we did above, right? So dot plot. I'm going to plot it for only the month. Wow, so this is how it looks like in a month. So it's at the beginning of the month, this was how it was for the useful count, then it goes down like that, right? Very cool and very nice. Wow. So we can do a lot of things. We can even do it for maybe for the first 5 days as you wish. So just as we did above, you can also do the same thing for here. So we can specify it like 1, or it was 4, right? 2, 5, right? Yeah, something like this for the rating. So within that short time, within just 1 month, at the beginning of the month, this was how it was. Then it went up, then it went down, right? So this is for a month, right? The distribution of rating over a month. So we have seen how to do a lot of things. We have answered a lot of questions. We have done a lot from this thing. You have done a lot over time, right? You have done a lot. Wow, that's quite a lot of time. So thank you for watching this long tutorial. In case you have any question or contribution, you can put inside the comment section below. So the basic idea of all that you have done is that you have seen how to be able to derive a lot of insight from a simple data set, right? You have seen how to derive a lot of insight using EDA. You have not even moved to the machine learning aspect, but you see the amount of insight you have gotten. So we're able to answer from the beginning. You to answer some questions on the drugs, the different types of drugs, right? Which of the drugs are the most popular drugs? Which of them are the drugs with the best reviews? All of these things. We're able to check for questions on conditions, questions on reviews, questions on the rating, questions on dates, questions on useful count, and several other aspects. So thank you for watching this long tutorial. In case you have any question or contribution, you can just put the comment question below. And in the next session, we'll be trying to see how to work on the ML aspect. So thank you. See you another time. Stay blessed.